In this video, we're going to be writing equations and inequalities from graphs and also from points. Well, let's take a look at this graph. We need to find the slope-intercept equation of the line. All right, well, the slope-intercept equation is y equals mx plus b, where m is the slope of the line and b is the y-intercept. Now, the slope of the line, that's the steepness, and that's the rise over the run. Or in other words, the change in the y's over the change in the x's. Now the y-intercept is where the graph crosses the x-axis. So in this case, the y-intercept is right here. So we have a b of -1. Now before we write the equation, let's go ahead and find another point so we can figure out the slope. I'm going to slide along the line until I come across another perfect point. And then going from left to right, I think, okay, how far down and over did I have to go? Well, I had to go down 1, over 2, and I'm counting the spaces. So the slope is -1/2. So we have a y-intercept of -1 and a slope of -1/2. Now we can write an equation with these two pieces of information. Y equals the slope times x plus b, or plus -1. And it looks a little nicer if we write -1 there. And there's our equation in slope-intercept form. Let's write an equation for this line. So we'll start by locating the y-intercept. So we have a y-intercept of -3. And I'm going to slide along this line until I find a second perfect point. And there's one right there. So going from left to right, I count how far up and how far over. So I went up 3 spaces and over 1 space. Well, the slope equals the rise over the run. So that's up 3 over 1. Now, when we have a 1 in the denominator, it doesn't need to be there, so we'll just write equals 3. So we have a slope of 3. And we understand that means up 3 over 1. Now we're ready to write our equation. Y equals the slope times x plus b, in this case, -3. To find the equation of this line, let's start by finding the y-intercept. So we have a y-intercept of -4. Now I'm going to slide along this line until I get another perfect point. And there's one right here. And we could keep sliding along here. So I'm just going to use this slope triangle here. From this point to this point, I went down 1, right 1. So down 1 and right 1. So I have a slope of down 1, right 1. Well, once again, when we have a 1 in the denominator, it's not important. So let's go ahead and rewrite this as -1. Time to write our equation. We have y equals the slope times x plus b, so in this case, -4. Now, when we have a 1 in front of a variable, it looks nicer if we leave the 1 out. So let's rewrite this as y equals -x minus 4. And we understand there's a 1 there in front of the x. All right, this one's a little bit more involved because we have an inequality. Notice that the space above the line is shaded. So that means all these points above the line are solutions to this inequality that we're going to be writing. Fortunately, we start the same. We will locate the y-intercept, figure out the slope, then we'll have to figure out the inequality based upon where the shading is and what type of line it is. All right, let's go ahead and locate and figure out the slope and the y-intercept first. We'll start with the y-intercept. So we have a y-intercept of 2. So this dashed line here crosses the y-axis at 2. Now the slope, I'm going to slide along this line until we get to a second perfect point. There's one right there. And so from the first point to the second point, I went up 1 and over 3. So we have a slope of up 1 over 3. Now, if we were just working with this line here without the shading, the equation would be y equals 1/3 x plus 2. But this is an inequality. When we're working with inequalities, we have to worry about if it's a solid line or a dashed line. So if we have a less than or a greater than, then that makes a dashed line. Now we use a less than or equal to, or greater than or equal to, when we have a solid line. And as far as where the shading goes, for less than or equal to, we use that when the shading is below the line. And we use greater than or equal to when the shading is above the line. All right, so here we have the shading above the line. So all these points above the line or greater than the line are our solutions. And we have a dashed line. So let's rewrite this equation as an inequality. We'll shade it above, and it's dashed. So that will be y is greater than 1/3 x plus 2. So I use greater than because it's shaded above, and the line is dashed. I will start here by finding the slope and the y-intercept. The y-intercept is at 8. And the slope, see, I slide along until I get it to another perfect point. And that is 1, 2, 3, 4, 5 spaces down and over 1. So we have down 5, right 1, or just negative 5. So if we were writing an equation, it'd be y equals negative 5x plus 8. Right, but this is an inequality because it's shaded below. But we do have a solid line. So it's going to be y is less than or equal to negative 5x plus 8. Now the reason I chose this inequality is because the shading is below the line, and it is a solid line. So I have that little equal bar there. Right, instead of a graph, we have some information here. We need to find the slope-intercept equation of the line that passes through this point with this slope. All right, so one way to do this is just to write out our slope-intercept equation. And the slope, well, we're going to substitute that for m, and we're going to substitute the number 1 for our x and negative 1 for our y. And what we're going to do is use that information to solve for b, because that's what we don't know here yet, is we don't know what the y-intercept is. All right, so here's our y from the point. So I have negative 1 equals negative 2/3 times positive 1 plus b, which is what we're looking for. Negative 2/3 times 1 equals negative 2/3. Okay, if you're good at working with fractions, you can just continue by adding 2/3 to both sides. But let's go ahead and work this out without fractions. And to do that, we're going to multiply by this denominator on both sides of the equation. So we're going to multiply the left side by 3, and then each term on the right side by 3. So I'm multiplying each term by 3. All right, so 3 times negative 1 is negative 3. 3 divided by 3 is 1, so those 3's cancel. That's why I just did that. So equals negative 2 plus 3b. Now we just need to solve this equation for b to get our y-intercept. Get a fraction for our y-intercept, and that's fine. So now we're ready to write our equation. Here's our slope, y equals negative 2/3 x plus b, or minus 1/3. And our slope y-intercept form. Okay, here we have 2 points, and we are going to write an equation of the line that goes to these 2 points. Now, this is a good situation to use what's called the point-slope equation, but I'm going to demonstrate how to write an equation of this line using slope-intercept form. All right, the first job here is to figure out the slope using these 2 points. Well, the slope of a line is equal to the second y minus the first y over the second x minus the first x, the change on the y's over the change on the x's. Just to make my life a little bit easier, I noticed that this is actually the leftmost point, so I'm going to use this as my first point. It doesn't really matter which one you do as your first point, but I'm going to use x1 and y1 with this point because it's the leftmost point. And here I have the second x and the second y. All right, I'm going to carefully put these numbers into my slope formula. So I take my second y and subtract my first y. So 3 minus 1. And I'll take my second x and subtract carefully my first x. So 7 minus negative 2. Notice we're subtracting a negative. So 3 minus 1 is 2. 7 minus negative 2, well, that's actually equal to 7 plus positive 2. We add the opposite. So we get 2/9 for our slope. Now in this next step, I'm going to use just one of these points. This one looks a little bit easier to use because there aren't any negatives. And I'm going to just label this x and y. You'll see how we'll use that in just a moment. Okay, here's our slope-intercept equation, y equals mx plus b. We now know our slope, and we have an x and a y from this point. Now we could have used negative 2 as x and 1 as y, but I chose this point. So let's see, y is 3, m is 2/9, x is 7, and what we're looking for is b, because that's what we don't know yet. We know our slope, and we're looking for the y-intercept. All right, let's go ahead and multiply 2 times 7. Now, rather than get common denominators and everything working out with fractions, I'm going to multiply each term by 9. So really what we're doing is multiplying both sides of the equation by 9. But by doing that, these 9's cancel. And now we don't have any more fractions. So we have 27 equals 14 plus 9b. Solving for b. Let's see, I'm going to switch sides here. I have b equals 13/9. All right, so once again, our y-intercept is a fraction, and that's okay. And we now know our slope and our y-intercept. So let's write our equation. Y equals 2/9 x plus 13/9. I hope these examples have been helpful. This is Mr. Ela, signing off.